Okay, for what we are going to be looking into is piecewise-defined functions. And now we're going to have, for these functions, they will be broken up into separate sections in accordance with what we have for various types of values in x. And now an everyday example for piecewise-defined functions, we would have included among the items tax brackets when federal returns are being done. Now, an example of a piecewise defined function where we have the function to be broken up into separate sections or pieces. We have f of x. Again, this is another way of saying y. So you have like the y value is equal to 2x minus 3 whenever the value of x is less than negative 3. Also, for other values of x, we have that y is equal to 7 whenever x is between negative 3 and 5 inclusively. And then whenever the value x, or the input, is greater than 5, we have the corresponding y value to be f of x is equal to x squared plus 1. So if we're looking for y values for the various input values we have in x, okay, say we have whenever x is equal to 4, we're looking for the y value that corresponds. Now for the value 4, now if you notice 4 is not less than negative 3, so 2x minus 3 will not apply. Now for 4, if I have negative 3 is less than or equal to 4, which in turn is less than or equal to 5, now 4 lies in between negative 3 and 5. So what would the y value be in this case? This would be for the portion that precedes the inequality. So in this case we have at 7. So we have whenever x is at 4, the corresponding y value in this case is going to be f of 4 is equal to 7. Now for the input value of negative 5, if you notice we have negative 5 is less than negative 3. That is a true statement. So what am I going to do with negative 5? Well, since negative 5 represents the next value that is less than negative 3, I'm going to take 2x minus 3, where x is again recorded at negative 5. So f of negative 5, I'm going to say it's going to be 2 times negative 5 minus 3. 2 times negative 5 is negative 10 minus 3. And negative 10 minus 3 is negative 13. So whenever x is at negative 5, the corresponding y value is at negative 13. Now for f of negative 3, now we have negative 3 is less than negative 3. That is not a true statement. So the first inequality description does not apply for the input. Now for the next one, we have negative 3 is less than or equal to negative 3 is less than or equal to 5. Now, while negative 3 cannot be less than itself, it is nonetheless equal. And so we have, since negative 3 belongs to the second inequality, we have for the output, again, that comes out again to the constant of 7. Now, for the input value of 10, okay, now 10 is not less than negative 3. 10 does not fall between negative 3 and 5. However, 10 is a value that is greater than 5. So what do I do with 10? I'm going to operate in accordance with the function portion where we have f of x is equal to x squared plus 1. So with x at 10, we're going to have f of 10 is equal to 10 squared plus 1. 10 squared is 100. And 100 plus 1 is equal to 101. So whenever the input value is at 10, corresponding y value is going to be at 101. Now, for f of 5, if we go back, now 5 is not less than negative 3, and 5 is not greater than itself. And just like what we had earlier with 4 and negative 3, 5 belongs to the compound inequality. So we would have negative 3 is less than or equal to 5. In turn is less than or equal to 5. So while 5 cannot be less than itself, it is nonetheless equal to itself. So again, we have in terms of what's going to become the y value whenever x is at 5, since that value belongs to this compound inequality, we had the function value or the y value to end up once again at 7. So we have f of 5 is equal to 7. Now let's say we have another piecewise defined function. And we have, in this case, all right, say we have f of x is equal to x minus 4 for values of x less than or equal to negative 2. And we have f of x is equal to the absolute value of x whenever negative 2 is less than x is less than or equal to 6. And we have, for the third portion, we have f of x is equal to x squared plus 2 for 6 is less than x is less than 14. And we have the f of x is equal to 3x for those values of x greater than or equal to 14. Now, let's say that if we're looking at evaluating the following, so we have f of 7. Now, the input value x is at 7. All right, so it doesn't belong to the first or the second inequalities, but 7 is such that 6 is less than 7 is less than 14. So I'm going to use 7 and apply it to x squared plus 2. So for x squared plus 2, this will translate out to 7 squared plus 2. 7 squared is 49. And 49 plus 2 is equal to 51. So f of 7 is equal to 51. Now for the input value of 4. Okay, now 4 is not less than or equal to negative 2. However, 4 does fall between negative 2 and 6. And so we have here, in terms of what to do with 4, we're going to take the absolute value of x, where we have x is going to be at 4. So f of 4 is equal to the absolute value of 4, and that is equal to 4. Now, in the case of what we have with 15, okay, now 15, out of all the inequalities to which this input belongs, okay, we have the last one to apply. So we do have, out of these inequalities regarding 15, 15 is greater than or equal to 14 is the only one that applies, and it being a true statement. So in terms of what to do with 15, I'm going to take 3 times that input, so you have 3 times 15. And so we have for f of 15, we have 3 times 15. And that comes out to 45. Now for f of 6, okay, now for the value of 6, okay, if you know 6 appears twice, and if you think of 6 as being inserted for x, now 6 cannot be less than itself. And if you notice in the second inequality, we have negative 2 is less than 6, and while 6 cannot be less than itself, we do have the equal sign to make the second statement regarding x equals 6 as a true statement. So what do I do with 6 in this case? I apply once again the absolute value. So f of 6 is equal to the absolute value of 6, which is equal to 6. Now for f of negative 9, negative 9, you have a relatively negative most value, and in fact we have negative 9 is less than already negative 2, so the first inequality, x is less than or equal to negative 2, is going to apply. So what I am going to do with negative 9, I'm going to apply negative 9 for x and take x minus 4. So this is going to translate out to f of negative 9 is equal to negative 9 minus 4, which will come out to negative 13. Right? And in the case of f of 14, okay, now for 14, the first inequality does not apply, the second one does not. Now for 6 is less than 14 is less than 14. Again, 6 is less than 14, however, 14 cannot be less than itself. And if I carry over 14 to the last inequality statement, now 14 cannot be greater than itself, but it is nonetheless equal to itself. So the last statement is going to be true whenever 14 is applied. And in terms of what to do with 14, we have multiplication by 3. So we have for f of 14, okay, this will be 3 times 14. And so we have for the y value whenever x is at 14 comes out to 42.